Hey everybody, how you doing? We're jumping into 12.3. We're looking at area this week. Haven't we already done area of triangles? Yes, but you can do more of it now. Aren't you excited? It's like, did you like your Brussels sprouts? Now get them with lima beans. It's so cool. Anyway, here we go. Jump into it. 12.3, area of triangles. Remember these problems when you had a regular polygon and you had to calculate the area of a regular polygon and you were using 1/2 AP squared? And they would give you something like this where they didn't give you the apothem, but they gave you the radius. And you had to do some Pythagoras theorem and things like that to get the apothem. Well, now that you know trigonometry, you can do even more. It's so exciting. If I were to tell you that this is a regular octagon, you could look at this and say, oh, well, then that's got to be a particular angle measure, right? That's got to be 45 degrees. And then that means that this little triangle right here is a 22.5, and that's a 90-degree angle. Well, now if I have this side length, I can say, oh, that's a 22.5-degree angle. That's a certain length. I know what the apothem is. I know what the radius is. I know what the meaning of life is. So it's pretty simple to do. We're going to jump into several ways of doing this. Alrighty, the Pentagon building is large and is a pentagon, believe it or not. We want to know how much area is enclosed by the Pentagon. Now, the Pentagon has a courtyard in the middle. We're going to pretend it's not there. It's a solid Pentagon building, okay? And if the walls are 921 feet long each, and an acre is this many square feet, how many acres is that building? It's crazy to be measuring a building in acres, I'm just saying. They measure farms in acres. Anyway, here we go. We need to figure out what the apothem of this is so we can use 1/2 AP. The apothem, and I know that because there are 5 angles here, each angle has to be 72 degrees because 360 degrees takes you all the way around. It's 360 divided by 5 is 72. And so this little part of the triangle, half of that little triangle must be 36. So 36 degrees, and if this whole thing is 921, then that means that this part of the triangle is 460.5. Now I have a sine opposite over hypotenuse, or a tangent opposite over adjacent, or a cosine adjacent over hypotenuse. That's not going to help me so much. But I can use 36 degrees to figure out what the radius is if I needed it, or what the apothem is. I definitely need the apothem. So I'm going to use the tangent opposite over adjacent, and I'm going to figure out what the apothem of this figure is. And then once I have that, I can use 1/2 AP squared, and I can go to town. So here we go. Tangent of 36 degrees, opposite over adjacent. I bring the a over here, right? I get it out of the denominator. So a times the tangent of 36 equals this. Then I can divide to isolate a by itself. 460.5 divided by the tangent of 36 will give me the apothem. Pretty sweet. Now that I have the apothem, I can use a equals 1/2 AP squared. I'm going to toss that in for the apothem. 460.5 divided by the tangent of 36 degrees. 1/2 times the apothem times the perimeter, which is 5 times 921. There are 5 sides, each of them 921 feet long. So just do a little simple multiplication here and divide by a trigonometric function, but it's really not that hard if you've got a calculator. And the answer is 1,000,000. Holy moly. 459,379 square feet. That's bigger than my house by a lot. Okay, so this is how many square feet, but I want to know how many acres. Each acre is this many square feet. So I've got to divide this many square feet by this many square feet, and I find out that the building is 33.5 acres. I just want to say I used to own a ranch. And it was big. Big. It was a third of that. I had a 10-acre ranch. We did a lot on 10 acres. That's a big building. They do a lot in that building, though, to be fair. They kind of like keep peace in the world. That's okay. Here's a cool little fact. If you know 2 sides and the included angle between them, you can figure out the area of any triangle, even if you don't automatically have the height, or if it's not a 90-degree angle in the triangle, if it's some acute or obtuse triangle. If you have 2 sides and the angle between them, you can figure out the area. Let me show you how. It's pretty swank. Here we go. Triangle ABC. If I know that measure A is what it is, I have the angle, I have measure A, and I don't have the height, I can use the sine of A, which is the opposite side, this altitude I don't have, divided by the hypotenuse of this drawn-in right triangle, right? So C, the sine is A, the sine of A is H divided by C. And so I can rearrange that to say that the height is C times the sine of A. Okay, that's cool. And so let's plug that into the equation. Then instead of 1/2 BH, it's 1/2 times B, the base of the triangle, times C times the sine of A. C times the sine of A is the height. So I don't have to calculate the height in some Pythagorean theorem, draw it in, try to figure out the angles. I can just use this formula, and I have that area is 1/2 times the base times this side, the adjacent side, times the sine of that included angle. Any triangle works. Is that phenomenal? You're welcome. Merry Christmas. Let's use it. Find the square footage of a triangular lot with sides of 80 feet, 90 feet, and 110 feet. If the angle between the two longest sides is approximately 46 degrees. 110, 90, 46 degrees. I don't care what h is. It will find itself in the course of this equation. It's pretty sweet. So I'm going to take these two sides. 110, that's my base. 90 is not my height, but 90 times the sine of 46 is my height. So sine of 46 is h over 90. The height is 90 times the sine of 46. Area is 1/2 times 110, this base length, times the height, 90 times the sine of 46. Plug all that in your calculator, hit do it, and you get 3,560.7 square feet. Pretty fantastic. It's a wonderful little tool to have in your bag. So just to put this in a formal theorem, Theorem 12.3.1 says that the area of a triangle is equal to the product of the two sides and the sine of the included angle. Product of the two sides and the sine of the included angle. We just rearranged it a little bit to make it look like that. So area is 1/2 times BC sine A, or 1/2 times AC times the sine of B, or 1/2 times AB times the sine of C. Whichever one you have, it works. The product of the two sides times 1/2 times the sine of the included angle. Okay? And so that is a fabulous little thing for you. This one's a little bit weird. Heron's formula. So Heron's formula lets you calculate the area of a triangle if you have all of the side lengths and you have none of the angles. I will teach you this. You will do some examples in class with this. But honestly, if I were faced with this problem, I wouldn't use this formula because this is just big and cumbersome and kind of hard to use. If I were faced with, here's the side lengths of this triangle, find the area, I would use some trigonometry and get the measure of one of the angles. And then I would use the last formula because that's a whole heck of a lot easier. But here's the way to do it if you don't have that option for some reason. Here we go. I have the side lengths A, B, and C. The area of the triangle is the square root of S times S minus A times, so S minus A times S minus B times S minus C. What's S? S is called the semi-perimeter. It is half of the sum of all the sides. So A plus B plus C times 1/2 is the semi-perimeter. Now, whatever that number is, you put here and here and here and here. See why this isn't quite as nice? But it does work. So we'll practice it a couple times and then you'll probably put it on a shelf and it'll gather dust. Because if you ever have to do this in real life, you'll say, oh, what's the area of that triangle? I know. I'm going to use this and this. I'm going to find that angle. And then I'm going to go on about my life. Okay, so here we go. Let's use it. Example. Area is 1/2 times AB sine of C. Oh, this is an example of the last one. Here I have 5 meters and 4 meters and 75 degrees. I'm going to just take the two things here, 5 times 4, 20, times 1/2, 10. Find the sine of 75 and multiply that by 10. Okay, here we go. 1/2 times 4 times 5 times the sine of 75 is 9.7 square meters. They just multiply all this together for you, but 4 times 5 is 20 times 1/2 is 10. The sine of 75 must be 0.97, so 0.97 times 10 is 9.7 square meters. Okay, that's how we can do that one. Let's get the area of this triangle. Here we are going to have to use Heron's formula. So semi-perimeter, 10 plus 7 plus 9 is 28. Sorry, 26. Just kidding. 26. Half of that is 13. So the semi-perimeter is 13. Now I'm going to go into that square root of 13 times, etc. I'm going to put 13 in everywhere that there's S. And then A was 10, B was 7, and C was 9. And it doesn't matter, by the way, which one of these you call A, B, or C. It's just the semi-perimeter minus a side times the semi-perimeter minus a side times the semi-perimeter minus a side. Okay? Just make sure you use different sides. So 13 minus 10 is 3, 13 minus 7 is 6, and 13 minus 9 is 4. 13 times 3 times 6 times 4 is 936. Square root of that is 6 radical 26 square inches. You can always leave things as a simplified radical. Okay, that's fine. If you don't understand that, join the rest of the world. No, just kidding. You can put a comment in the questions below and I'll get to it as quickly as I can, or not, and we'll just deal with it in class. Okay? So that, ladies and gentlemen, is it. Peace be with you. We'll do lots of these in class tomorrow. God bless you. Jesus loves you, and so do I. Good night.